Hello everybody, welcome to One Math Army. I am Muhammad Tafi Hassan, your mathematics mentor in this channel, and we are going to be discussing about the divisibility rules of 12 and 13. We have discussed the divisibility rules of 10 and 11 in the previous video. Now let's see what we have. Now before we start the session, subscribe to the channel to mark your attendance. Now let's see what divisibility rule for 12 has for us. Now if a number is divisible by 3 and 4, then the whole number is divisible by 12. Now here I have my example 3,74,80,460, and let's see if this number is divisible by 3 first, and then we'll check for 4. Now first of all, this number is not divisible by 3 over here because the sum of the digits is not a multiple of 3. As you can see, the sum of the digits is 32, and which is not divisible by 3, and the last two digits are 60, which is divisible by 4, but in order for a number to be divisible by 12, it should be divisible by both 3 and 4. So this number is not divisible by 12 over here. Now for the proof, first of all you have to find the factors of 12, and I got them written over here like 1, 2, 3, 4, 6 and 12. Now we have to find a pair of factors whose product is 12 and they are co-prime to each other, excluding 1 and 12. So we already know that 1 and 12, 1 is the factor of every number and 12 is the factor of itself, so obviously. So excluding 1 and 12, we have to find a pair of numbers who are co-prime to each other and the product is 12. So here I get the only pair is 3 and 4, because 2 and 6 are not co-prime. They have 2 as their highest common factor. In order to be a co-prime, the highest or common factor should be 1. So here I got that 3, 4. So if a number is divisible by 3, 4, then the number is divisible by 12. Now this method does not only work for 12, it also works for numbers like 14, 15, 18 and 22, etc. Now let's see the divisibility rule for 13. Here we have to multiply the units digit by 4 and add it to the rest of the digits. So here I got my example 845, and I have taken the units digit, multiplying it times 4, so I get 20 over here. 5 times 4 is 20, and I'm going to add it to the remaining number left, which is 84, so I get 104. Now again, further simplifying that, I'm going to get this. See, the number has been simplified to a very less number, calculable number. So it was 845 and I got this to a small number, so I can even further simplify that by multiplying 4 times 4. I get 16, and 16 plus 10 is 26, and now we all know that 26 is divisible by 13. So here's the calculator. I have calculated the 845 divided by 13. You can see that it is divisible by 13, and that's what I got here. Now let's see the proof again. So I have taken my ABCD and expanded that again. So here I get 1000 times A plus 100 times B plus 10 times C plus D. Now I have written 1000 as 1300 minus 300 and so on. So basically I'm converting all the terms into a term which contains a multiple of 13 over here. So here I expanded this again over here, as you can see, and I have taken common all the terms which are divisible by 13. So that is 1300A plus 130B plus 13C plus 13D. So now we know that this over here, this whole term is divisible by 13. So the only thing we have to check is this minus 300A minus 30B minus 3C minus 12D. So you can see how I got that 12D over here. I written D as 13 minus 12 times D over here. So I have grouped all the 13 terms and I have got the remaining terms over here. Now I have taken common minus 3, so I am left with minus 3 times 100A plus 10B plus C plus 4D. Now we know that minus 3 is not divisible by 13. So the only thing we have to check is this 100A plus 10B plus C plus 4D. So if we assume that ABCD is divisible by 3, then this should be divisible by 3, and this is nothing but this over here. This is nothing but this. So we have that multiply the units digit by 4 and add it to the rest of the digits. So that is exactly what I got here. So 4 times the units digit. I have removed that. First of all I have to remove that, then I am left with these 3 numbers. So for ABCD the expanded form is 1000A plus 100B plus 10C plus D. But if I remove the units digit, all of them are going to shift to 1 times right. So the tens place is going to become the ones place now, and the hundreds is going to become the tens, and the thousands is going to become the hundreds. So that's I have removed the unit digit over here and written the expanded form 100a plus 10b plus c plus 4d. I have multiplied that to 4, so hence proved. I'll meet you in the next video, guys. Till then, bye bye. Subscribe to the channel if you didn't yet. If you liked how I solved my proofs, like the video. I'll meet you in the next video.